Okay, what do we know about geometric series that converge? Okay, so first of all, what's the rule? They converge if the absolute value of the ratio is less than 1. Okay, and if they do converge, then we know they converge to what? Yeah. Okay. What we're going to do is we are going to take functions and represent them as geometric series. So for example, 1 over 1 minus x, write it down. Okay, so what does this look like? 1 over 1 minus x. What does it look like? What did you say, Dan? Maybe I need to be more specific. Do you notice any similarities? Doesn't it? If this is a over 1 minus r, then we could say, all right, our first term is 1 and our common ratio is x. So we can write 1 over 1 minus x as the series from n equals 1 to infinity of x to the n. That needs to be a 0. That's probably should be a 0. Sorry about that. Our first term is 1. I'm not going to write 1 times r to the n. Yes, a geometric series is a, yeah. So in the beginning of our chapter, we looked at series that did not have any x's, and we determined that they were convergent if r was less than 1 versus, okay. So now we're writing, I'm talking. Now we're writing power series, okay? You know, like the other day when we were working with series and we were talking about their radius of convergence, okay, so that's what we're working with. Now we have a power series. It's not just like a normal series. Now it's a series with x and n. So now, what do we know about a geometric series? We know a geometric series converges when the absolute value of r is less than 1. Okay, well, in this case, this is going to converge when the absolute value of x is less than 1. So our interval of convergence for this guy is -1 to 1 without even having to do the ratio test. Score. Yeah, that is an I. Is that better? Yes. This is 1 plus x squared plus x cubed plus x to the 4th plus x to the 5th all the way until infinity. Yeah? Okay. Okay. So are we okay with the process that we just took? Friday's a rough day, huh? Would you rather use long division? Maybe. Do you remember how to long divide? So we're taking 1 minus x. No, that's not right. We're taking 1 divided by 1 minus x. So 1 times what equals 1? 1. Then I take 1 minus x times 1. And we subtract. What are we left with? 1 times what is x? You see where this is going?
Oh.
And that pattern is going to continue. Okay, which just ends up being the series from n equals 0 to infinity of x to the n. You know what? I really think I prefer using a geometric series to do that. Oh, you would rather do long division? Okay. Now, I'm glad I don't have to make a Taylor polynomial out of this, right? Isn't it nice not to have to make a Taylor polynomial? Yeah, okay. You don't care. Yeah, but it has to be in this setting, right? We need to be able to use the a over 1 minus r. Okay, now we're going to put a little twist on it. Could you center this series at x is -3? Okay, so what would we need to see in our equation if we wanted to be centered at x is -3? We would need an x plus 3. Well, if we're going to have an x plus 3, then we're going to have to add 3 and subtract 3 so that we're adding 0, right? So I'm going to write this as 1 over 4 minus the quantity, bless you, x plus 3. Just inscribe right there for him. That changes the value of the function. We don't want to change the function. So by multiplying by 1 or adding 0, we change nothing except how it looks. Okay, well, is this in our form a over 1 minus r? Is it? This is technically the -3 because we're subtracting the quantity. So this -3 came here. And this 3. Okay, is this 1 over, or excuse me, is this a over 1 minus r? That's not a 1. It needs to be a 1. Okay, so how do we force it to be a 1 without changing the value? Multiply numerator and denominator by 1/4. So we have 1/4 over 1 minus x plus 3. Is it what? It is. We're used to not having fractions inside of a fraction, but this isn't actually like what we're going for here. I want the power series, okay? So we're gonna write this series from n equals 0 to infinity. What is our first term? 1/4. And then we have our R value, x plus 3/4 to the n. Yeah. Okay, now you are welcome to leave it like this, or you could also write it as 1/4 to the n plus 1 times x plus 3 to the n. Where the heck did I get that from? This is 4 to the n times 4, so we could make it 4 to the n plus 1. Okay. Now, what is our radius of convergence? Because we know it. It's 4. How'd you get that? Okay, so Andre guessed, but he guessed correctly. This is our R value right here. And our R value needs to be less than 1, which means x plus 3 needs to be less than 4. So if I asked you for the interval of convergence, we're centered at -3. Our radius is 4. And I know that those are parentheses. Why? Because it's geometric. We set it up to be geometric. Our endpoints aren't going to converge. R has to be less than 1. Absolute value of R has to be less than 1. If it's equals to 1, nope, it's not going to converge. If we use a geometric series to create it, yes. Okay, so we have 4/5 minus x, and I want it centered at -2. I'm going to give you a few minutes to see if you can get to the a/1 minus r without my assistance. You're welcome to work with your neighbor. So that's factored out. So this is really that's why.
Like, better than all, like, you could say in the classroom.
Okay. Please make sure that when you do this, okay, we want x plus 2 in parentheses. And there's a subtraction right here. So this is really our -2, which means our +2 gets combined with the 5. Okay, so make sure you think about order of operations. Okay. So 4/7 over 1 minus x plus 2 over 7. Evan, how'd you write your series? N equals 0 to infinity of. Okay. Aiden, what's our radius of convergence? 7, which means our interval of convergence would be what, Rachel? -9 to 5. So this is x is -2. Add 7, subtract 7. Okay. Here are the operations that we can do with power series. I would.
Yeah, yes. I think there's like most schools like even nationally have like an outside.
So people are getting emails from colleges that like what the colleges now.
Yeah, I don't know. It's weird. How do you get
National grids.
like
National grids. Oh, yeah.
is it based on cases?
So the PSAT is assignment, and then you go through an application process.
You get it for only 7 months.
And you go.
How many people do they take for finals?
Most of them. I think the only way you don't get like to finalists from semifinalists is if you either like don't fill out like the application or your SAT or ACT isn't high. Because you have to like submit a score that like basically reinforces that your PSAT is like correct.
It's usually like 1,400 bucks for
Yeah. PSAT is this year I think the last is like 13.90 for our state. But it varies by state. Like it's easier to get a new test.
Okay, so as you're writing this down, the biggest thing that I need you to take away from this is we can create a series like if we know that f of x is this series, we can actually plug in different things for x. Like we can plug in 5x, or we can plug in x squared and readjust our series as needed. So what I would like you to imagine this is like x squared, or like x to the 5th. This is just a different power than what this is. Oh, okay. In her class. And someone else that I did not have in calculus.
I just remember they're always on the app. Like,
It's just 1 year we had 2.
what do we usually have?
We let this one.
Like, or there's some years.
I mean, since I've been here before. Okay. Do we have this written down? Andre, so right. Sure. Okay. All right. So I want you to consider this guy right here.
Well, yeah.
Okay, okay, okay. Now, does this look like a over 1 minus x?
I got an X. No, not PFD. Oh, not correct. Yes.
I thought-
I'm gonna give you 1 minute to find me A and B.
That's so funny. I should put a t-shirt. Should show the
I'll even give you a happy picture.
Is that your dog?
Yeah, my husband's, yeah, he's coming back with him today.
What is it?
Where did you say? Stop. What are you gonna name him?
Echo.
Oh, that is cute.
Coming. What?
Oh.
Did he say fail?
Just made it worse by explaining it. What is it? What is it end up being?
Oh, well, yeah. Like,
Just the numerator.
duh. Oh, yeah.
B is 1/2. A is. A is negative 1/2.
Nope,
No, it's A is also 1/2.
they're both positive 1/2.
Then the other side of the equation is negative. We're still 8.
Okay, so you're getting 1/2 for both, right? Okay, so we have 1/2 over, I'm gonna write this as 1 plus x. And then 1/2 over, I'm gonna write this as 1 minus x and take out a negative. Why would I do that? Now I can write them. So we have 1/2 times negative x to the n minus the series from 0 to infinity of 1/2 times x to the n. Okay, now, is this one series? No. So we could, well, how do we write it as one series? Factor it. Okay, now we could do some work and figure out what -1 to the n minus 1 really was. Okay, this really isn't like super nice, is it? What if I told you there was another way? You want to try another way?
Supposed to be a lesson that
There's always other options. So here we go. X over x squared minus 1. Could I write this as x over 1 minus x squared? But throw negative out front. So really what I have is negative x times 1 over 1 minus x squared. How is that helpful? What? So we have negative x times x to the n. Oh no, x to the 2n. Why is it x to the 2n? Because it's x squared to the n, right? Now, do you see this guy right here? This is x to the first power. Do you agree? So x to the first power times x to the 2n power gets us this. Way better than partial fraction decomposition. Well, honestly, in my notes, I had us doing partial fractions, and as I was doing it, I thought there's a better way. So let's look at it. Because how many of us wanted to figure out that this was the same thing as -2 to the -2 x to the n?
But like, are we done? We solved it the other way today.
I mean, I probably should be fine, but it's just not gonna match. Yes. Okay, so now that we've learned that lesson, let's try this one. You say USub? Well, if we were integrating, that would be a great idea, but we're not integrating. Okay, so if I rewrite it like this, 2x squared times 1 over 1 minus negative x cubed, I see a over 1 minus r. Do you? Okay, so I can write this as 2x squared times the series from 0 to infinity of a times, what are you taking a picture of? That's a baloney answer. You're not taking a picture of notes. I'm waiting for you to write it down. And then took a picture of it. Okay. Let's go ahead and separate -1 to the n from x to the 3n. You didn't like that?
No, what Rachel said to me.
Oh. Okay, so what I have is 2 times -1 to the n times x to the 3n plus 2. Do you agree? What's our interval of convergence? What's our interval of convergence? Yeah, -1 to 1. We come back up to here. What is our r? And it needs to be the absolute value less than or equal to 1. Well, if it's x cubed, cubed root of 1 is 1. So what?
Did you look at like, say we were given that and told to find that.
Yeah, either way. Yeah, just since we modeled it after geometric, we do less work by using r instead of having to do the ratio test. Did I answer your question? Okay. All right. Next one, we have 2 more examples. What are we gonna do with this one? I see 1 over 1 minus x, the quantity squared, but there is no way for me to make that 1 over 1 minus x or 1 over, or a over 1 minus r. You don't like where this is going? Why is this bad? So -1 over 1 minus x is the series. N equals 0 to infinity of negative x to the n. I want you to represent 1 over 1 minus x, the quantity squared, as a series. You are welcome to go through all of the work of finding derivative, second derivative, third derivative, figuring out the pattern and writing it. Or we can do this way. All right. Now, what is the derivative of this series? N equals 1 to infinity. Not everybody did that correctly on their quiz yesterday.
So why is it one? Like, was it can be n minus?
Right. So since our exponent goes to n minus 1, if this was 0, we'd have x to the -1, and that's not polynomial. What'd you say? I'm sorry.
I just always put one.
Yeah. You said that n equals 40.
All right. Now, what is our radius of convergence? Okay, that's not what I asked. Our interval of convergence is -1 to 1 for this guy right here. Our radius of convergence is 1. Now, our derivative also going to have a radius of convergence of 1. However, what's true? The only thing that stays the same is we don't know about the endpoints. So we got to check the endpoints. How about if you're female, you are going to check the endpoint of -1. If you're male, you are going to check the endpoint of 1. For the derivative.
Well, then it's just negative. But so then the so it converges. No, it goes to the-
Okay, what did I have you guys do? Okay, when we plug in -1, it simplifies down to what? And that. Okay. What is n x equals 1 simplified to? Okay, and does that converge or diverge? So our interval of convergence is -1 to 1, endpoints not included. Okay, but we still have to check them if we're doing derivatives or integrals. Guess what our last example is? Almost.
This is all I've used this entire time.
I found a spot.
I just don't make it.
No, you kind of write big and sloppy. Okay. No.
Wait.
All right. So I want the representation for the natural log of 5 minus x. What's gonna help us? Integral of what? Yes, it would be negative. Okay, so we have the integral. I'll just put the negative out there, of the series of n equals 0 to infinity of, ooh, hold on. Can't do that yet, can I? Does that look like a over 1 minus r? Excuse me. And honestly, since we are having to integrate, I think that it would be wise for us to write this as x to the n over 5 to the n plus 1. So that when we do our derivative, we don't have to be crazy. Excuse me, antiderivative. All right, so what is our series? Negative sum from n equals 0 to infinity of x to the n plus 1 over n plus 1 times 5 to the n plus 1. Technically, there would be a plus c, but we won't worry about that. What is our radius of convergence? Really, suppose on my website, or my food section, right? Okay. 5 is our radius of convergence. Five is our radius of convergence. So from -5 to 5, we can check our on Tuesday, we will do damage control from this homework assignment. Yeah, but if you don't do your homework assignment,
That's the most.
Yeah.